Hey everyone, this is Rubaina Sharan. In this video, I'll be explaining about the website that I created. So this video is going to be for the future me so that I can come back and see what I have done in this project. So it's going to be slow, effortless and boring. If you're up to it, then let's get started. First, I'll show you the demo and then explain what is the structure and then the code. So this is the username prompt where you can give any name as you like, but it should not be already there in the database. So it will check whether it is a unique username or not and then saves it. So as you saw, Rubaina was already there, so it said username already exists, please choose another. Let's just give Itachi. Great. Now this is the home page where I have done some typing effects for the word learn and also some magical sparkles to the mouse. If you ask me what was my inspiration for this website, nothing. I just simply thought of a website where we can learn anything and everything, but of course I couldn't achieve it because it had so many limitations. I'll tell you all about later. And then here comes the question, what do you yearn to learn? Yearn means nothing but wanting something very much. So here we have 4 main categories: programming, technology, business skills and soft skills, and each of them have its own subdivisions. You can choose whatever you want. Also down here I have links of all my social sites, so if you have any query you can ping me. This is Hashnote, a blogging website. I have written each and every steps of building this project and their codes too, like a readme file, just documenting my process. Yeah, you can go through if you want. Of course, the Git repository is also linked to see the code, but here too I attach the codes just for the completion. So now I'm going to choose Python from here. And boom, here comes a freaking set of 20 questions. Yes, you heard me right. How can I just give you a learning journey simply? You have to yearn it. Now, after completing these 20 questions, you get your scores, and based on the score, the journey will be created. You have to wait for some time because Google's Gemini is going to generate the learning journey for you. Now, you must have noticed something in the background. Yes, I thought so hard about how to engage you people while waiting for the learning journey to be generated. So I created a torch thingy in the mouse so that you could find who is in the background. So yeah, try to find out. Here is our 10 chapter learning journey for Python. You have to complete the current chapter to move on to the next one, and also the next chapter can be opened only after a minute of opening this current chapter. And here, as I mentioned, who was in the background? Yes, it's our Gojo Satoru. It also shows what kind of journey is created based on the score, whether it is a beginner, intermediate or advanced. You can see that the AI has created a script which real-time examples and friendly explanation and not some monotonous paragraphs. I gave the prompt specifically like that to make it create sentences like that. Now, as I told, when I click the next chapter, you can see that it's locked. And also if I click the generate next journey, it says it can be open only after a minute. And after we complete all these 10 chapters, you could see that cheering confetti is inserted to congratulate you. Yeah. And yeah, it's pretty much what's there. And here is the about page with the description of the website, and then the dashboard where you can see the progress, name and scores of your skills, where you can also continue the journey where you have left. And here is the profile page where all the details about the user is present with their achievements, and also a tiny note section for you to take notes if needed. And that's the end of the demo session. let's see the basic structure of the website. This is an important disclaimer. I have to tell you guys that I'm a noob and this is the first time ever I'm creating a full stack website, and so the super ultra developers who can even close their eyes and code, y'all don't get worked up, please bear with me. First of all, let us recall some basics of a website. What's a website? Think of it as a digital storefront or a virtual space where information is stored and shared. So when you type a web address in your browser, several things happen behind the scenes. The browser sends an HTTP request to the web server hosting that site. So what is an HTTP request? Well, that is a basic thing that everyone knows, but this is the core concept that also later explains how the front-end and back-end connection is done. So it is a request, which is a message that the client sends to the server to request a specific resource such as HTML or CSS or a JS JavaScript page or even an image or any data. The server then responds with a HTTP response that has the requested resource or an error message if it has failed. In essence, websites work by storing content on servers and delivering it on demand to clients over the web. Hey bro, get me the HTML file, would you? Well, it's not a person, that's not how it works. They have their own language.
Who's they?
Like, this is how HTML request will be, like get index.html HTTP, and the server's response will be 200 OK. This 200 OK means that the request was successfully received and understood, and the server has processed it without any error. Another key part of a website architecture is DNS, which is domain name system. DNS acts like the internet's phone book. It translates human-friendly domain names like www.learnwithrubaina.com into an IP addresses that computers use to locate servers. So when you first visit a site, your browser asks a DNS resolver for the site's IP address. Once the IP is found, the browser sends the HTTP request to the correct web server. So in summary, a client initiates a request by entering an URL. The DNS then resolves this URL into an IP address, which the client and the server then exchange data using HTTP. Now, you all would have seen different types of websites. Let's see their types. Static website is a website where content is displayed exactly as it's stored. They don't change content based on user interaction or data retrieval. They are typically built using HTML, CSS, and JavaScript. So in this website, you can see that they're just static. There's no change whenever any user. There's no input given by the user, so it's just static. And dynamic website is a website whose content is generated or modified on the fly, meaning it changes based on various factors like user interactions, time, or other variables. So in this website, you could see that based on the interactions that the user is giving, it changes according to it. We all know e-commerce websites. Even though we have zero balance, putting that green waste in the cart is a never-ending game. And we know blogs, a regularly updated website or web page where individuals or organizations share content, typically in the form of posts or articles. We know portfolios, an online space, typically a web page or collection of web pages used to showcase a person's or company's work, skills, and achievements. And also education sites, online platform designed to provide learning materials, resources, and tools. So now, what is web development? What are their essentials? Firstly, let's see about front-end, also known as client-side development, focuses on the graphical user interface of a website or web application, specifically the part where the users see and interact with. It uses CSS and JavaScript to create responsive, accessible, and dynamic interfaces. And the next is Backend. Also known as server-side development, it focuses on the infrastructures and logic that runs behind a website or application, making it functional. It involves building and maintaining the server, database, and APIs. Thirdly, we'll see about databases. MySQL, MongoDB, etc. are all backend databases that can be used to store the web data, but I have used PostgreSQL in this project. PostgreSQL is a language for querying and managing databases, and it is a database management system, DBMS, that uses SQL and helps in complex applications and rich data types. And also the version controls makes your job easily by documenting, keeping the timeline, and also we can see the overall development of the project through these, like example GitHub, AWS code commit. There are many more. So now let's come to our website. The structure of my website, like, let's see, now that you know the basic terms, let me tell you what essentials I used in my website. I used ReactJS as the front end, FastAPI as the backend, PostgreSQL as the database, GitHub as version control, and also I used Gemini 1.5 Flash experimental version as an AI integration. Well, I will explain these terms eventually, wait for it. As you can see, the website is dynamic and responsive. Yes, it is adaptable according to different screen sizes too. Also, I have designed some layouts for the mobile screen too. I will just insert the mobile layout here. Welcome to Little Lecture Session 2. So let us see about the ReactJS that I mentioned earlier. This is the front end. So imagine your website is like a Lego castle. Each piece of Lego, like door, window, or tower, can be clicked, moved, or changed. ReactJS is like a magical Lego builder that helps you create websites using small reusable pieces. We call that components in ReactJS that can change without rebuilding the whole castle. Now, ReactJS is a JavaScript library made by Facebook to build fast interactive websites. For example, if you want a button to change color when clicked, you write a HTML for the button, add JavaScript to listen for click, and manually change the color. Repeat if you need 10 buttons. But with React, you can write one component called color button and just use it 10 times. React handles the clicks and color changes automatically. So in React projects, we usually name the main component as app because it stands for application, the entire web application's starting point. We use the name called component, which is the reusable building block like a Lego piece that controls how a part of web page looks and behaves. Now coming to Axios. Axios is a tool that helps you talk to a server from your website and get data. You use Axios to get data from your backend or an API like the quiz scores we have, and send data like user answers or progresses, and then update or delete things. Well, now if you think this is just similar to an HTTP request, yeah, you are right to question that, because Axios makes HTTP requests. It's just a tool to make those requests easier, cleaner, and more powerful than using the built-in method called fetch. Like every browser has a built-in method called fetch to make HTTP requests. Like you can see, this is how a HTTP fetch request is made. This works fine, but this requires more code, doesn't automatically handles errors, and doesn't support all features easily. But yeah, Axios makes HTTP easier. It is a library that uses HTTP under the hood, but gives you a cleaner, powerful, and developer-friendly way to make requests. Now, as you can see, here's the same request using Axios. Tailwind CSS is a toolkit that helps you design beautiful websites faster using short, reusable classes. I will compare a styling of a button with and without Tailwind for you. So without Tailwind, to make a so-called a red button, you write a lot of CSS, right? Like background color, padding, and border radius. And then you switch between the files and keep writing new class names. But with Tailwind, the same thing can be done in one line. No extra CSS files and all in one place. Now that's all the terms that you need to know from the front end. Now let's move on to the back end. Coming to the back end, we need to know what is an API key. API key is an access password. It's like a token that identifies your application when calling a third-party API. It tells the provider like, hey, this is an authorized user, allow this request please. And it's like a messenger or a middleman that allows different software applications to talk to each other and then share information on or perform tasks. So now you might think, why does everything sound similar? Be it HTTP, Axios, or an API, all of them does sound same. Fetch and respond thing. What's the difference? Well, all seem to do the same thing. They're closely related and part of the same process of communication between a client and a server, but they're not quite the same. Each has a specific role in that flow. So now, think of the process like ordering food at a drive-thru. You, the client, shout your order into the intercom. Then the intercom system, which is here the HTTP request, carries your order to the kitchen. The kitchen staff here, who is an API, prepares your food based on the order. Now the delivery person here is our Axios. It's a tool that makes it easier for you to shout your order and get the food back quickly. The response, that is your food, comes back through the same system. All these pieces work together to make the client-server communication happen, but they each have distinct roles. Now that we have understood what are API and Axios, let us see what's a FastAPI. FastAPI is a modern, super fast tool to build APIs, backend servers using Python. FastAPI is used to build the backends, the part of the website or app that saves data, sends data, or processes the logic or connects to a database. Now, while you're using a FastAPI, you get a free Swagger API interface, like a playground for testing your API, It is a framework for defining APIs using a human readable and machine readable format. So this is the Swagger API where we can test the backend. If we give any input here, it will check and say whether it's already there in the database or not. So basically this is how the backend works. We just design and do the putty tinkering in the website with the front end to make it look cool. Now see here, these are all the endpoints that we connect in the app.js file in React codes. You will understand when you see the code. Now instead of going to the website and seeing the result each and every time we change the code and commit, we can use these API endpoints to check whether the backend is working correctly or not, or how it works, or what kind of result is giving in the backend. Now to check like that, we should give this try it out and give the username here. Now I'm giving Rubaina and click the execute button. Here you can see the JSON script. See, URL is a command line tool used for transferring data with URLs. It says what type of endpoint and URL is used in this. So there are two types of requests you need to know: get and post. Get is where you can give input and check the output in there, and the input you gave will not be stored but used only for the checking purposes. Whereas in post, you can give the input and it will forever be stored in the database. I'll show that next. Now here, this is the request URL. We saw the explanation about the FastAPI request before, right? Yeah, this is that URL request that we were talking about so long. Here you can see the code is 200 and the response which is true to the column exists, which means the username Rubaina already exists in the database. Now shall we give another name and test? Yes. Now it says false. These are all just the description about the type of response, whether it is successful or not, and then the error validation, etc. Similarly, we can try one post request. We'll try submitting the score. Here we should give the input exactly according to the JSON format. So now let's give an unique username, score, and its skill. So this is basically what we get from the website. Instead of getting from the website, we manually give the values here. So now when you give the execute, the actual learning journey itself is created according to the input values we gave. So yeah, that's all about the FastAPI Swagger UI. Now let's see what is UVCon. UVCon is a high performance asynchronous server gateway interface. That is a web server for Python. It's designed for running asynchronous web applications, particularly those using frameworks like FastAPI, and is known for its speed and efficiency. Now let's see about SQL Alchemy. It is a Python library that simplifies working with databases. So using Python codes itself, we can create tables in our database. I'll show you that later in the code. Now that the lecture session is over, let me tell you how I deployed my project first and then go to the code, because there are things that we might not understand if we directly go to the code. First of all, the deployment and management totally differs according to your needs. If you're a broke, unemployed person with Asian parents, then you probably won't be able to pay the freaking $20 for mere hosting of a website. Yeah, I deployed with what I have got in free tiers. So let us see about Vercel. where I deployed my frontend. Vercel is a platform that simplifies building, deploying, and managing web applications, especially for front-end frameworks like React. So this is where I hosted the front end, and for the back end I deployed it in Render. Render is a cloud platform that simplifies building, deploying, and scaling web applications and services, supporting various programming languages and also the databases like PostgreSQL. So as you can see, we can see all the messages for each GET and POST requests and their responses, and even the Gemini's response in the console. And as for the database, I used Neon, which is a cloud-based PostgreSQL database platform that simplifies managing and scaling databases for web applications. It offers features like serverless architecture and automatic scaling. So it integrates with tools like Vercel and Render, enabling developers to efficiently store and query the data. So now you can see here, right, we have the data. Also, like we saw in pgadmin, we can use queries to get a specific result from the data. Sorry, we didn't see pgadmin, right? So this is pgadmin, a powerful open source graphical user interface administration tool for PostgreSQL database management system. This is where I initially locally maintain the database. As you can see, we can type queries and see the output as per the requirements like we usually do in SQL. And now the unsolvable problem that I faced just because I wanted to complete this project without spending any money is that the Render is a free tier party that sleeps after 15 minutes from the last request, meaning if it had been 15 minutes since it gave any GET or POST request that keeps the connection between the backend and frontend alive, the Render starts sleeping, and so after some time, if we try to use the website, it shows error because there ain't any connection with the backend. Remember, the user have to give their username at the beginning of the site itself. So if Render is sleeping, then who will check with Neon for the database and tell whether the username is already existing or not? So to solve this problem, ChatGPT CC gave me a solution, but for a top-end website, this is not recommended. So there's this thing called Uptime Robot, which is basically a website monitoring service that checks if your websites or APIs or servers are up and running by sending periodic requests and alerting you if they go down or have issues. So yeah, that's how the overall deployment is done. You could ask me, why not use Firebase instead? Well, Firebase is easy to set up and use, great for real-time features, but I had some syncing issue with Firebase. Also, for customer API logics with Python, Firebase had limitations, and if we want to scale up the project, it might cost us in Firebase. So yeah. As I mentioned before, I used Gemini 1.5 experimental version for this project. I know Google will end its experimental version soon, but I had no choice. All the other AI companies that offered API keys for text creation had so many limitations, like no credits and tokens that can be used per API request, which were like 3 per day, or even worse, and direct payment only. So I got no choice but to choose this temporary but efficient experimental version of Gemini, which also has token limitations. Tokens are nothing but number of words we use. So for a single request, it cannot exceed a certain number of words in its text generation. Now let's move on to the code section that we were waiting for. Let's see the backend first. The name of the backend folder is Project X. Don't know why I kept it. Now this is a .vs code folder. This is the first file in Project X. This code just tells the VS Code software to suppress the warnings related to Git when you are working in a large repository. If you add this setting, you are telling VS Code that I know the project is big, don't keep warning me about Git limits. So yeah, it's basically just that. Now what are node modules? Node modules is just a folder that is automatically created when you install packages in a Node.js project when we use npm install command in the terminal. So this folder contains all the code libraries, that is dependencies your project needs. Along with the node modules, other files like package log JSON and the package JSON are also downloaded. Wait, Node.js? What is that? Right, well, we all now understood ReactJS, which is a front-end library that runs in the browser and controls what users see, right? Now, Node.js is nothing but a runtime environment that lets you run JavaScript outside the browser, like on a server or your laptop. Before Node.js was created, JavaScript could only run inside browsers like Chrome. Now, Node.js opened the door to use JavaScript to build server apps, APIs, CLI tools, build tools, and more. Yes, there's nothing complex about it. Now, this is the public folder where all the files that are public can be stored. This file is where all the favicon and HTML files will be there. Favicon is just the icon that you see in the browser tabs. Yeah. Yes, you see what I kept as my favicon? It's yell. Now this is index.html. Let's say line by line. Doc type HTML. This tells the browser this is an HTML5 document. That is the latest standard of HTML. It's always the first line in every HTML document. And then this just begins the HTML document and sets the language to English, EN. And then head section, the metadata, and behind the scenes setup starts from the head. Contains information not shown on the page but important for the browser, SEO, and devices. And meta charset UTF-8 is the character encoding, allows the use of all common characters, symbols, and emojis, supports multiple languages and symbols in your app. And then this is where we add the favicon, that is the public URL, and that I added here. That's the tiny icon shown in the browser tab. Public URL is a placeholder that will be replaced during build with the path to your public folder. And this is essential, this meta name and viewport. This line is essential for responsive design on mobile devices. Tells the browser to scale the site properly on phones and other tablets. So just to be responsive. And here's the theme color that sets the color of the browser address bar on mobile devices and some desktop browsers. And this is description is shown in the search engine results. It's like a short summary of your website's purpose. This just says that website created by the great Rubaina, that I wrote it. Yeah, and then this is Apple Touch icon for the iOS users. It's like a shortcut icon on their home screen. And this link to manifest enables your React app to behave like a progressive web app, which is PWA, installable, offline capable, etc. Manifest JSON file includes name, icon, theme color, and start URL for the app. It's a web app manifest file. It tells the browser and mobile devices how your web app should look and behave when it's installed to the home screen. And robots.txt, it means do not block anything. In other words, allow bots to crawl the entire website. So I just allowed it to see whatever it wants, so I didn't block anything. And then PyCache is a folder automatically created by Python. It stores compiled Python bytecode files. When you run a Python script, Python converts it into bytecode, which is a low-level code the Python interpreter can run faster. So instead of recompiling your code every time you run it, Python stores the bytecode in the PyCache folder to make your program start faster next time. And this is readmd file, which is a markdown file commonly used to just explain what's in your project. So it usually appears on the home page of your GitHub repository. Database.py. This file is setting up your PostgreSQL database connection using SQL Alchemy, which is a tool that lets Python talk to databases in an easy, clean way. So let's go line by line. The first line, from SQL import create engine. This imports the create engine function. It is used to connect your Python code to a SQL database like PostgreSQL. And then the next line imports the declarative base function. It is used to define database models, tables using Python classes. You later use this base to create tables by defining classes that inherit from it. And this SQL ORM imports session maker, which is used to create database sessions. A session is like a short-term connection to your database where you can read or write data, and this is your connection string. Very important line. It tells SQL Alchemy how to connect to your Neon PostgreSQL database. Now you can see the URL has the username as NeonDB owner, which where we deployed our database. Neon is the website where the database is there. As I said earlier, initially while creating the database, the URL will be created. So in here, that URL can be used to test the website locally, but while deploying the website, I used Neon, which provides us the space to store and use it in the site. And now we are creating the engine, which creates the actual database engine, which is a connection object. This engine is how SQL Alchemy talks to your PostgreSQL server. And the session local creates a custom session factory that will not commit changes automatically, not auto-flush data until you say so. Use the above engine connection to talk to the DB, and you later use this like DB equal to session local, something like that. And the base is, it creates the base class for all your database models, which is tables. Later you define classes like class user base in your app and home, where we store the databases. Here comes the main.py. In Python, it serves as the entry point for a program or a module. Now these first lines you see, these are all the required imports and setups needed. FastAPI, SQL Alchemy, coarse middleware which allows the React to talk to the backend across domains, and the operational error which catches database connection issues. These are all that. And the next three lines, database import session local, engine, import models, from schemas import. You see these, we created the engine and the session local in the database file. Remember that we are importing here. Also these models and schemas are the app specific database models that we will see next. And the other dependencies, also the logging, and that helps in debugging, etc. for debugging stuffs. And engine.dispose and all the engine specifications. It says dispose, that clears old connections, pool size 5, which ensures about 5 simultaneous database connections can be made, and the pool settings, which are helpful for platforms like Render that sleep apps, often causing stale connections. And pool pre-ping verifies connection health before use. And this coarse middleware, where we allow origins. This is very important. All allows all front-end clients to access the API. So here it is important what you give in the allow origins, because I spent a lot of time finding this error. You can see that the Vercel produces an unique URL each time it is redeployed. So giving the old URL or even the main domain URL here created incorrect AI generation. So at last giving star inside the allow URLs gives access to the API, and there won't be any error in the text generation of AI. At least that's what I found. If you have any other ideas, please feel free to mention in the comment section. And this models.base.metadata, this auto creates tables based on SQL Alchemy models. And this is the session local, which I mentioned earlier. This is to inject the database session into API routes safely. That's why we gave the try and finally. And here comes our API key. Headers equal to content type application or JSON. This sets up the Gemini API endpoint, and headers for using requests. This is the API that can be copied from the Gemini page where they offer APIs. So using this URL only, we call the AI to answer for the prompt that we are giving. And this def has taken quiz today. This function checks if the user has already taken a quiz today that we saw in the website, right? If you already taken the quiz today, then it shows the prompt that you have already taken the quiz. So are you sure you want to take it again? So that's the prompt we saw. So this is the function that uses retry logic in case of database connection failures. And get API calls today function is for rate limiting or usage tracking queries. How many API calls were made today? And generate and store journey function. This is a prompt for Gemini to generate a journey tailored to skill and score. This makes a post request to Gemini API using requests.post. I have specifically set certain things in the prompt so that the script is made accordingly. Like include real-time examples, use a varied teaching style to avoid monotony, etc. This function handles retries up to 3 times for Gemini failures or timeouts, and there are lots of logs in between which I added every time I get any error so that I can find it in the render console or local terminal. This is to find the JSON text within the script generated by the AI, because during the generation of the script, double quotes or any special characters might make the JSON format misunderstand the code and might end up in error, which, well, this made the prompt creating step a lot harder. And here it parses JSON response inside triple backticks. And here we have a bonus fallback logic. If Gemini fails repeatedly, it falls back to the smaller prompt where only 3 chapters and 50 word scripts is limited. If that fails too, it creates a placeholder journey with default values. This ensures users never get stuck. Now here and the end you can see the for loop, which acts as the except block. If any error has occurred in the journey creation, then the placeholder text will appear. And now the function generate next chapter. It checks if user and learning journey exists and validates the chapter index. Checks if current chapter is completed and whether next chapter exists. Returns the next chapter from the journey, which is already pre-generated. This is the part of your chapter by chapter unlocking logic. So here, these are the endpoints that needs the FastAPI to check the Neon database to verify the needful. Here this is to check whether the username already exists or not, and this is to check whether the user has already taken the quiz today or not. And this here is the post endpoint where it stored the score secured by the user, and also it saved the entire learning journey created by Gemini. And similarly, these are all get and post endpoints to receive and send the data. So here you see this is a warm-up that I created in case the uptime robot has failed. So what this does is it sends a test prompt to the Gemini to warm up the connection while the user is surfing in the home page itself. So it will have some time to get ready until the user finishes the quiz and all and come to the journey creation. By the end, by then the connection becomes smooth. Now this is models.py. This is the table that we were talking about all this time. SQL Alchemy makes the Python code to convert it into an SQL table that has the required column and table names. First is the user table where all the usernames are saved. Second is the user skill where all the terms related to the skill, like the skill name, score, journey, progress percentage, are all created. And then the question table where all the questions for the quiz are stored, and then the timestamp whenever the API call is made is also stored. This is schemas.py. This code defines pedantic models which are used in the FastAPI backend for request validation and data serialization or deserialization. In FastAPI, pedantic models define the shape of a request and response data, like whether it is a list or a string or boolean or an integer. And this is test.href, a file that I created for testing the AI. It's just a small testing file that asks how are you to the AI to test whether the AI is responding or not. Like I said before, these are all the packages and dependencies which will be downloaded automatically when you run the command npm start in the terminal. Requirement text is just for the developers to know what are all needed for this project. So now let's jump to the front end, shall we? Here everything is same as that of the backend. Here we have this extra file called assets where we can put any images or font styles. So here is our Goja song. Now, what are the use effect hooks? It is the fundamental part of React for managing side effects in functional components. These side effects are actions that occur outside the normal rendering process, like data fetching, DOM manipulation, or setting up subscriptions. So this is our app.js. This code defines the core of the React web application. It's the main app.js file that powers the website's navigation, user session, and custom experience like the animated cursors. Yeah, this acts as the glue for the entire front end. Firstly, importing required libraries and components and other pages. As you can see, the const username where the local storage use state and loading are set. The username is stored in the browser memory, which is the local storage, so users stay logged in even after a page refresh. Loading is used to show a spinner when transitioning. And then the next use effect, as we saw, well, this is the custom made cursor that adds a glowing cursor trail when the mouse moves, and skips this feature on mobile to avoid lag, because we don't move along in the mobile, right? We only have the touch feature, so we neglect that. And it dynamically creates and deletes the cursor particles when using on the desktop. And the next use effect is the username, where when the username is detected, it shows a loading spinner for 1 second before showing the site. So for that the timer is set, and then if loading, it returns this, which shows a spinning circle animation using Tailwind CSS until the page is ready. Yeah, while I've said this is just the loading scenario, how to spin the loading circle. And then the next username prompt, the router path is set. This controls what component is shown at each URL. So when the path is username prompt, it shows a form to enter the username, and then when it only has the slash, it redirects to home if username exists, else redirects to prompt. If the URL is slash quiz and skill, it opens a quiz page for the skill. And similarly, if the URL is slash learning journey or slash dashboard profile about, for them respectively, each the quiz page or AI learning plan or the respective page is passing the username or shown, so that these are all the URL routes which are set. Now this is the dashboard.js file where the users can view all the skills they've started learning, see their score, learning level and progress for each skill, and even click a continue learning button to resume a learning journey. So if you see the code, in the first 3 lines, the link enables client-side navigation between the pages, and the use state is used to store the data. Use effect runs logic when the component loads, and the Axios, as we saw earlier, is used to fetch data from your backend API. And then the next 2 lines is export default function dashboard is initializes an empty list of skills. When data is fetched, this state gets updated. So initially it's just an empty list of skills. And then the next use effect is basically it's the try and catch function, where it runs once when the dashboard loads, reads the username stored in the browser, calls your backend, which is the get used user data username, likely hits your user skill table. On success, sets the skill data into state. If there's an error, example network issue, it logs it into the console. And then the next code says the div function, and h1 just uses Tailwind CSS to make it look beautiful. Just black background, white text, and centered content. And then the next is the skills.map, where each card shows information about for a skill, and continue learning links to learning journey, which opens a page with the AI generated learning chapters for that skill. So this is our learning journey JavaScript code. Let's see line by line. The first line says it imports use effect and use state, and then the use params, navbar, axios, and canvas confetti. And then FA bars and FA times are the icons for opening or closing the mobile sidebar icon that you see. And component definition, which defines the main component learning journey, and then the state variables, skill and username. Skill is for root, and skill is from the root, and username from local storage. And setting the const variables. Now the use state for setting the learning journey chapter, which stores the full learning journey including all the chapters, and then use state of 0 for tracking which chapter is currently being viewed, and then tracking the loading state, and then storing the error messages. And then this last generated time use state is for keeping track of when the last chapter was generated. And then generate message, which stores any UI message regarding chapter generation timing. And then show celebration, which is used to trigger the confetti celebration overlay. And then is sidebar open. Set is sidebar open is for opening and closing the state on small screens for the sidebar. And then fetching the journey on load, which uses the use effect, where it runs on when the component mounts, and then inside it fetches the learning journey for the user and selected skills. And then const handle progress update is for sending a post request to backend to mark chapter index as completed or incomplete, and updates the local state. If final chapter is completed, index triple equal to 9 shows the confetti celebration. And then generate next chapter is for checking if enough time, that is 1 minute, has passed since the last generation. And then calls the generate next chapter API with the proper parameters, and updates the chapter content and increments the current index. Also handles errors and message display. And this is for toggle sidebar on mobiles for the opening and closing of the sidebar. And then chapter content condition is where it gets the current chapter or an empty object. And then is unlocked is for it takes a chapter is unlocked if it has content or it's the first chapter. So it says that it's the first chapter if there is no unlocked chapter. And then you can view a chapter only if the previous one is completed, and that's for that. And the loading state, if loading and not generate messages, shows it's been a while loading unless it's just a rate limit message. And then the error display shows error message on failure. And the written statement is for UI render, full UI rendering including navbar, mobile header with toggle, sidebar, and all of that. This is the profile file which is the React component, and let's see line by line. First, it imports all the same use effect, use state, use callback, and a link from the React router DOM, and then React Quill, which we use as the nodes. For that, we import this, and then the CSS gives it a snow theme, and then Axios navbar are also imported, and then the component definition here as well for profile, and then similarly the state variables, username, user skills, nodes, loading error, and similarly the use effect, which fetches the user data. When the component mounts or username changes, it fetches user data from the backend using the Axios as we saw earlier, and then updates the user skill state, and it handles loading and error states. Nodes change handler, which updates the node content and stores it in local storage, wrapped in use callback to avoid unnecessary re-renders. And then the loading UI displays the spinning loader, and then the error UI shows the error if something went wrong. And then the main return JSX is for main container with black to gray gradient background, and then the welcome says shows some welcome message, brief subtitle, and a button to go to the dashboard as well. And the achievements section where it displays the user achievements in responsive grid, and each skill cards shows the skill name, score, progress, and last attempt date. Adds staggered fade in animation with delay per item, and adds, and the React Quill is for the notes taking area. It adds a rich text editor for user notes using the React Quill, and then custom toolbar with headers, formatting, links, and lists. And then these are the styles where animate, fade in, delay, and the Quill editor are all styled here. So this is our quiz.css file, just the styling stuffs. So starting, it has the quiz BG full screen background image that we set for the Gojo Satoru, and it's this BG : before is for the dark spotlight overlay, and it's just the styling of mouse X and mouse Y and transparent and positioning and all that stuffs. This adds a spotlight effect that follows the mouse using CSS variables. And then for the mobile, the spotlight adaptation is done using add media. So on small screens, the spotlight size is reduced for better UX, and so that the circle is kept for 50px. And then the content layer on top ensures that the quiz content appears on top of the overlay so that the min H screen is set, and then padding of 1.5 REM is set, and then style radio buttons for the quiz options is set using type radio, and then style disabled buttons for makes disabled buttons look visually dimmed to indicate they are inactive. And yeah, that's it for the CSS. Now this is our quiz JavaScript code. Let's see the code here. All the import statements of React, Axios, useparams, navbar, and all that stuffs are imported. And then the component and state setup, where it declares a functional component quiz and then extract the skill name from the routes parameter, and then the navigate is a function used to change routes. And here all the use state hooks are set, like for questions, current question, selected option, etc. All these are use state hooks that we saw earlier for profile, and as well use effects, that same use states here. And then here comes the use effect for fetch questions that runs when the component loads or skill changes, and calls backend API to get questions for the given skill. And this if and else statement is for if the response has questions, it stores them and initializes uses answers, and sets an error message if fetch fails or returns empty. And this use effect for update position gets the background div and calculates mouse position in %. And this convert mouse or touch coordinates to percentage and sets them as custom CSS. And this handle touch move and mouse move for desktop, touch move for mobile interaction. All these stuffs are the positioning of the mouse and all those stuffs. And finally, the window dot add event listener and remove event listeners for adding and cleaning up event listeners for preventing memory leaks. And then handle option select is for storing selected option for the current question, and then it updates the corresponding index in user answers. And then the handle next button checks if selected answer is correct. And then the set score, set show score, submit score, all these moves to the next question or shows final score, prevents moving forward without selecting an option. And then handle back button goes back to previous question and restores previously selected answer. And then the submit score to backend is sends the score to backend and redirects to the AI generated learning journey page. And then the component JSX rendering, the written statement is the wrapper div with the black theme and spotlight background. And this div class name flex item center justify center is for the if the quiz is over, then it shows score and then waiting message. So you see there your score braces score is where the score is showed, and then the questions is divided by the question's length, so it stores the score there. And then the waiting message is also shown. And if quiz is ongoing, shows current quiz and options here. And this radio buttons and label HTML for renders radio buttons for each options. And then this is where we give the back and next or submit buttons depending on progress. And then here comes handles error and loading spinner if questions not loaded yet. And then this is the custom pop-up we set if no option is selected, so please select an option to continue. That pop-up is shown here. And that's it, that's the quiz page. So this is our take quiz prompt file. Similarly, here also we have the same import statements for use effect, use state, and use params, axios, all the same. And then component declaration for take quiz prompt, and the local variables and state for skill, username, prompt shown, and navigate. And use effect for checking quiz eligibility on mount, which calls backend API to determine if the user can take the quiz for the given skill. And URL includes both username and skill. Example, can take quiz Rubaina Python. And this is for if API says quiz already taken, that is can underscore take equal to false, then shows the confirmation prompt, else redirect directly to quiz. And then This console error triggers on initial render or when any dependency changes. And this is handle response. If the user clicks yes, navigates to quiz forcibly with force equal to true, and if user clicks no, goes back to the dashboard. And this written statement you see here is for the rendering full screen black background with scented model card if prompt shown is true, and shows message to confirm retake. And these are just buttons of yes and no to no, go back, and yes or retake, and that's it. This is the username prompt file. Here the same import statements and component declaration for username prompts, and state and hooks for useState, input username, error, loading, and navigate. And similarly the use effect for if username already exists in local storage, and then the handle submit asynchronous for submitting button logic, and then the loading, it sets the loading to true and clears any previous error message, and then the await axios is for calling back backend API to check if the username already exists, and this if and else is for username already exists in database and it shows error. It says username already exists, please choose another. This is just the prompt that we see initially in the website. Yeah, it's nothing complex. And then the catch and if else for error handling, and finally set loading as false. And this JSX UI is for full screen black background and white center box with padding, rounded corners and shadows, all these styling stuffs. And then header is prompts user to enter username, and then if any error shows it in red, yeah, it's and then the submit button and the loading button is all the stuffs for styling and loading for the username prompts that we saw initially. So this is thus the about JS file is for just the showcasing what the website is, and it's just the paragraph sentences. Let's go to the home JavaScript. So here is our home JavaScript code. The purpose of this file is just the component serves as the landing page of your app. So the animated learn, the skill category explorer, the links to external platforms like GitHub and LinkedIn that I attached at the end of the page, and the warming up, all these stuffs are in the home page. And here we come the React and the link navbar import statements, and this you see is the GitHub blog envelope. These are all the icons for the social site links that I attached. And then React hooks, useState, useEffect, and useRef for state, lifecycle, and DOM axis. Similarly, the component states and useEffect hooks, and here is the useEffect for animated learn word. So as you see, the const word learn is set and index 0. So after the interval, it just slices the word, and it shows it as a typing effect. Gradually types out learn one letter every 500 milliseconds, like a typewriter effect. And this use effect is for waking up the backend, so prevents cold start delays on free render hosting by pinging the backend once when the page loads. And skill data stores all the categorized skill options, and this JavaScript text written is the nav bar receives refs to scroll to home or skills section and shows the username. And the giant word learn is animated letter by letter. Font is the custom niblax that I uploaded in the file. The skills explorer, and then when in view, the skills section fades in over 2 seconds. While scrolling, it transitions like a slow fade-in effect when you see in the website. So that's this thing. And here you see the div content. Each skill category is clickable and expandable. Inside each category, skills link to check quiz / skill name. So it uses max height plus opacity for slide down animation. And then here the social skills footer that I attached my links. And then the custom CSS files for the style sheet and font face and fade in, pulse slow, etc. Just styling things. So this is our index.js file. Similarly, we have the import statements of React, React.dom, and index CSS app. All these are imported, and then the root gets the DOM element with the ID root from your HTML and initializes a React root container using the modern create root API. And this renders the app component inside the root DOM element wrapped in the react.strict mode. That's it, development only wrapper. It helps detect potential problems like side effects or deprecated methods, has no impact in production. That's it. It's very simple. And here comes our navbar file. Just the navbar thing we see on the top of the website. It's imported all their links and used it from React. So these are the icons that we use in the mobiles, the 3 lines that you see in the mobile, and the X for the close icon. And component definition for navbar, and use state for a sidebar open state to control whether the mobile sidebar is visible, and the scroll handlers for scroll to top, which is for window. The behavior should be smooth. It smoothly scrolls to the top home section, also closes the sidebar. And the next scroll to skills. While clicking the skills is smoothly scrolls to the skills section. And then here the nav wrapper is a sticky navigation bar at the top of the screen with black background, and the border is at 50, keeps it above other elements. In mobile view, hamburger plus sidebar is set as we saw earlier, and the sidebar panel and sidebar content for the mobile links and sidebar overlay for backdrop is all set. And then for the desktop view, horizontal navigation bar is set, where the desktop nav items is a responsive horizontal list of navigation links, and underline is set. Also the profile icon while clicking which goes to the profile page, instead of text shows a profile SVG icon here. So that's it, that's the navbar. And Vercel.json is specifies the version of the Vercel platform, and this Vercel.json file is set outside the file of Frontend and Backend. It's for the GitHub to specify to the Vercel these stuffs before deploying. So the builds says that it defines how Vercel should build your project. So the source is the quiz frontend, because Vercel is just for deploying the front-end documents. So it says the source is only quiz Frontend, and we use this Vercel state build uses the static build plugin, which runs the build command npm run build itself. So in terminal we type the npm run build and the npm start commands to deploy or the running the codes. So Vercel, we set what should be run while we are deploying. So it says npm run build, and then the config specifies the output directory after build. So the React apps created by create React app output static files into the build folder by default, which here is inside quiz Frontend. And the roots captures the, as I said, while allow origins, here the same is source is set as star because it captures any path requested by the client, and the destination is quiz Frontend. Obviously the maps the captured path to the same path inside quiz Frontend directory. Yeah, that's all the codes. That's everything you need to know about this code section. Everything is covered. Now that the code session is over, I'll show you the flow summary. This is the flow summary where the submit, front end, and post request and backend logic is done. And these are the tools and roles as we saw: the React as front end, Axios as communication, and FastAPI as the backend logic, PostgreSQL as a database, Vercel, Render, Neon are all the deploying websites. So yeah, these are the tools that I used. And finally, I'm going to share the problems that I faced while doing this project. So the first one is, you would have seen I hard-coded the database URL and API key in the code. That's actually not an ethical way. We have to create a .env file, which is an environment file that has the secret URLs and keys that you don't have to show in the public. And then there's a .gitignore file that has these files in it, so that the Git itself will understand that it should not commit these files into the hub. But what happened to me was I had an error. So GPT said I have to delete all the node modules and clean the repository to get rid of this error. So I just followed that, but cleaning the repository is a hella freaking tough job. When I was at the end of completing the project, my .env file and .gitignore file got messed up, and due to some changes, the git change that we see in the VS Code, right? The git changes, that count exceeded 10,000, which blocked the pushing into the GitHub, but committing was available. So I had to create a mirror clone of my repository and clean the large files and then sync it again with my original file, which changed most of my paths and my code messed up. So I had to do it again, and after finishing the rework, again it showed 10,000 changes. That's when I got frustrated, and somehow I came to know about the BFG repo cleaner, but even that did not solve the problem. So I had to use the GitHub itself. Even now I'm using the GitHub for committing and editing the files for this project. If you guys know how to do it or how to get rid of that 10,000 changes, leave your ideas in the comment. I would love to know the solution. And the second one is the parsing of the journey text in incorrect JSON format that led to the prompt fall to accept block, which gave the default filler messages. Parsing is nothing but the process of converting the JSON string into a structured data object. Because we are using words in the prompt, the AI creates JSON format FastAPI scripts, but there occurs issue with the double quotes and other stuffs because of this JSON. So to find out this error, I spent literally 3 days. How did I find out? I tried asking GPT, Grok, Perplexity, Claude, Gemini, but none gave result. But after including this logging statement that you see, I was able to see the AI script in my terminal, but I couldn't see it in the website, meaning the AI script is being created, but there's an issue in showing it in the site. So this logging thing is very important while you're coding. But why did this simple logging thing took 3 days? If you ask me, yes, it's simple until you know where to add the log. I thought I was falling back to the except log because the API call was not made properly, but then I tried a test file that you saw earlier. You remember the test_hf, we send just a how are you message to the Gemini. So that ensure the call is made, but the output is not seen in the website. Also finding the right free AI took me a lot of time in the first place, because the freaking credits, as I mentioned before, is in every models made it worse. And then I thought it's because of the tokens. Finally I found it because of parsing. Then I tried the raw response before after parsing, and yeah, fixing the captcha will sync the website output with the terminal. And then the third one is the Gemini that I used in the Google Studios while copying the API key. Remember to click the box in Google Credentials API and services where generative language API key can be located. This is important because enabling this only will make the API create language scripts. So that's the end of the video. Thank you so much for watching this video. Until the next time, bye bye.